Hello and welcome to this video walkthrough on determining feature importance in a breast cancer dataset using Python. In this Jupyter notebook, we will explore 3 different methods for determining feature importance. We will start by getting importance from coefficients, then move on to getting importances from a fitted tree-based model, and finally, we will get importances from PCA. Before we dive into the code, let's take a quick look at the summary of the notebook. This notebook demonstrates 3 methods for determining feature importance in a breast cancer dataset using Python. We will be using code cells for importing libraries, loading and preparing the dataset, and plotting the results. Now that we have a brief overview of what we will be doing, let's get started with the code. Hello and welcome to this video walkthrough on determining feature importance in a breast cancer dataset using Python. In this Jupyter notebook, we will explore 3 different methods for determining feature importance. In the current cell, we have some code that imports necessary libraries, loads the breast cancer dataset using the load_breast_cancer function from splurn.datasets, and sets some plot stylings using RC params. This is just the initial setup for our analysis, and we will be using these libraries and dataset throughout the notebook. In the next cell, we will load the data and start preparing it for analysis. In this cell, we are importing some necessary libraries for our analysis. We are importing NumPy, pandas, load_breast_cancer function from splurn.datasets, and matplotlib.pyplot. We are also setting some plot stylings using RC params. This will help us to make our plots look better and easier to read. Finally, we are loading the breast cancer dataset using the load_breast_cancer function from splurn.datasets. This dataset will be used throughout the notebook for our analysis. In the next cell, we will convert this dataset into a pandas data frame. In this cell, we have a simple markdown statement that says convert to pandas data frame. This means that we will be converting our breast cancer dataset into a pandas data frame in the next cell. We have already imported the necessary libraries and loaded the dataset in the previous cell. Now, we will be using the pd.concat function to combine the data and target arrays into a single pandas data frame. Once we have converted the dataset into a pandas data frame, we will be able to manipulate and analyze the data more easily. In the next cell, we will see how we can use pandas to explore and prepare the data for analysis. In this cell, we are creating a pandas data frame using the pd.concat function. This function combines 2 data frames, one containing the breast cancer dataset's features and the other containing the target variable. We are also assigning column names to the data frames using data.feature_names and y for the target variable. This will make it easier to manipulate and analyze the data. Finally, we are using the head function to display the first 5 rows of the data frame. The next cell will demonstrate how to use pandas to explore and prepare the data for analysis. In this cell, we are preparing the breast cancer dataset for analysis. We are doing this by scaling the features and splitting the data into training and testing subsets. Scaling the features is important because it ensures that each feature is on the same scale, which can improve the performance of certain machine learning algorithms. To split the data into training and testing subsets, we will use the train_test_split function from the splurn.model_selection library. This function randomly splits the data into 2 subsets, one for training the machine learning model and one for testing the model's performance. We will also use the standard scalar function from the splurn.preprocessing library to scale the features. This function standardizes the features by subtracting the mean and dividing by the standard deviation. In the next cell, we will explore the data further and prepare it for analysis using pandas. In this cell, we are importing 2 libraries, standard scalar and train_test_split. These libraries will be used to prepare the breast cancer dataset for analysis. Standard scalar is a function from the Splurn.preprocessing library that standardizes the features by subtracting the mean and dividing by the standard deviation. This is important because it ensures that each feature is on the same scale, which can improve the performance of certain machine learning algorithms. Train_test_split is a function from the Splurn.model_selection library that randomly splits the data into two subsets, one for training the machine learning model and one for testing the model's performance. We will use this function in the next cell to split the data into training and testing subsets. In the next cell, we will use these libraries to further prepare the data for analysis by scaling the features and splitting the data into training and testing subsets. In this cell, we are preparing our data for analysis by splitting it into training and testing subsets. We first drop the target variable y from our dataset and assign it to x, while assigning y to y. We then use the train_test_split function from the Splurn.model_selection library to split our data into training and testing subsets, with a test size of 0.25 and a random state of 42. This will allow us to train our model on the training data and evaluate its performance on the testing data. In the next cell, we will further prepare our data for analysis by scaling the features using standard scalar from the Splurn.preprocessing library. In this cell, we are scaling our features using standard scalar from the Splurn.preprocessing library. We first create an instance of standard scalar and assign it to SS. We then use ss.fit_transform to scale our training data x_train and assign it to x_train_scaled. Similarly, we use ss.transform to scale our testing data x_test and assign it to x_test_scaled. Scaling our features is an important step in preparing our data for analysis as it helps to ensure that all features are on the same scale and have equal importance in our model. In the next cell, we will explore the first method for determining feature importance, which involves getting importance from coefficients. In this cell, we are introducing the first method for determining feature importance, which involves getting importance from coefficients. This method involves using a logistic regression model to fit our training data and then examining the coefficients of the model to determine the importance of each feature. We will explore this method further in the next cell, where we will use logistic regression from the Splurn.linear_model library to fit our training data and extract the coefficients. Stay tuned! In this cell, we are preparing to determine the feature importance of our breast cancer dataset. We are using a logistic regression model from the Splurn.linear_model library to fit our training data. Then, we are creating a pandas data frame called importances to store the importance of each feature. We are sorting the data frame by importance in descending order using the sort_values method. In the next cell, we will visualize the feature importances using a bar chart. But for now, we have successfully prepared our data for analysis by fitting it to a logistic regression model and extracting the feature importances. In this cell, we are visualizing the feature importances that we obtain from the coefficients of our logistic regression model. We are using the plt.bar method from the matplotlib.pyplot library to create a bar chart. The x-axis of the chart represents the attributes of our dataset, while the y-axis represents the importance of each attribute. We are using the importances data frame that we created earlier to plot the data. We are also setting the title of the chart to feature importances obtained from coefficients using the plt.title method. To make the chart more readable, we are rotating the x-axis labels by 90 degrees using the plt.sticks method. Finally, we are displaying the chart using the plt.show method. In the next cell, we will introduce a second method for determining feature importance, which involves using a tree-based model. But for now, we have successfully visualized the feature importances obtained from our logistic regression model. In this cell, we are introduced to the second method for determining feature importance in our breast cancer dataset. This method involves using a fitted tree-based model. We will explore this method in the next cell, but for now, let's focus on understanding what this cell is telling us. The cell simply provides a heading for the second method, which is to get importances from a fitted tree-based model. This method will be explored in more detail in the next cell. In this cell, we are introduced to the second method for determining feature importance in our breast cancer dataset. This method involves using a fitted tree-based model. We will explore this method in the next cell, but for now, let's focus on understanding what this cell is telling us. The code in this cell fits an XGBoost classifier model to the training data and extracts the feature importances using the feature_importances_ attribute of the model. The feature importances are then sorted in descending order and stored in a pandas data frame called importances. The importances data frame has two columns, attribute and importance. The attribute column contains the names of the features in the dataset, and the importance column contains the corresponding feature importances. This cell is an important step in our analysis because it allows us to identify which features are most important in predicting whether a breast tumor is malignant or benign. We will use this information to create a bar chart in the next cell that visualizes the feature importances. In this cell, we are creating a bar chart to visualize the feature importances obtained from the first method we explored, which involved fitting a logistic regression model to the training data and extracting feature importances using coefficients. The plt.bar function is used to create the bar chart, with the x-axis representing the attribute names and the y-axis representing the importance values. The importances data frame is used as the data source for the chart, with the attribute column providing the x-axis values and the importance column providing the y-axis values. We also set the title of the chart using plt.title and rotate the x-axis labels using plt.sticks rotation equals vertical. Finally, we display the chart using plt.show. In this cell, we are introducing a new method for determining feature importance in the breast cancer dataset using Python. This method involves using PCA, which stands for Principal Component Analysis. PCA is a technique used to reduce the dimensionality of a dataset while retaining as much of the original information as possible. In this case, we will use PCA to identify the most important features in the dataset. We will be using the sklearn.decomposition library to perform PCA. However, we will discuss the implementation details in the next cell. For now, let's move on to the next step in our feature importance analysis. In this cell, we are importing the PCA module from the sklearn.decomposition library. PCA stands for Principal Component Analysis, which is a technique used to reduce the dimensionality of a dataset while retaining as much of the original information as possible. We will be using PCA to identify the most important features in the breast cancer dataset. However, we will discuss the implementation details in the next cell. For now, let's move on to the next step in our feature importance analysis. In this cell, we are using PCA, which stands for Principal Component Analysis, to identify the most important features in the breast cancer dataset. First, we are fitting the PCA model to the scaled training data using PCA. Fit x_train_scaled. Then, we are plotting the cumulative explained variance by the number of principal components using plt.plot. The x-axis represents the number of principal components and the y-axis represents the cumulative explained variance. We set the title of the plot using plt.title and display the plot using plt.show. In the next cell, we will be creating a pandas data frame called loadings to store the principal component loadings, which will help us identify the most important features in the dataset. In this cell, we are creating a pandas data frame called loadings. This data frame will store the principal component loadings, which will help us identify the most important features in the dataset. To create this data frame, we are using the pd.dataFrame function and passing in 3 arguments. The first argument is the data we want to include in the data frame. We are using pca.components_.tnp.sqrt_pca.explained_variance_ to calculate the principal component loadings. The second argument is a list of column names for the data frame. We are using a list comprehension to generate column names that start with PC and end with the number of columns in our training data. Finally, the third argument is the index for the data frame, which is the column names from our training data. In the next cell, we will use the head function to display the first few rows of the loadings data frame. But for now, let's focus on understanding how we created this data frame. In this cell, we are using the head function to display the first few rows of a pandas data frame called loadings. This data frame was created in the previous cell and stores the principal component loadings, which help us identify the most important features in the dataset. The output of this cell shows the first 5 rows of the loadings data frame, which includes the principal component loadings for each feature in the dataset. The columns of the data frame represent the principal components, and the rows represent the features. In the next cell, we will use this data frame to create a bar chart that visualizes the correlation between each feature and the first principal component. But for now, let's focus on understanding the contents of this data frame. In this cell, we are creating a bar chart to visualize the correlation between each feature and the first principal component. We start by creating a new data frame called PC1_loadings that sorts the loadings data frame by the PC1 column in descending order. We then select only the PC1 column and reset the index to create a new data frame with 2 columns, attribute and correlation with 1. Next, we use the plt.bar function to create a bar chart with the attribute column as the x-axis and the correlation with 1 column as the height of each bar. We set the color of the bars to #087E8B and add a title to the chart that says PCA loading scores, first principal component. Finally, we rotate the x-axis labels vertically and display the chart using the plt.show function. In conclusion, we have explored different methods for determining feature importance in a breast cancer dataset using Python. We have seen how logistic regression and XGBoost classifier models can be used, as well as how PCA can help identify the most important features. We have created a pandas data frame called loadings to store the principal component loadings and use it to create a bar chart that visualizes the correlation between each feature and the first principal component. I hope this walkthrough has been informative and helpful in your data science journey. Thank you for watching.